Hi, everybody. Happy to be with you today and talking about building sustainably with mass timber. I'm not sure what your day looks like, but this picture sort of adequately looks a lot like what our day is here. It's rainy and cloudy, mostly cloudy. I think the rain's starting to end now. And we're really tired of it and ready for it to go away after 4 straight days of it. So happy to have you with us today. And again, if you have any questions of me, please don't hesitate to put them in the question box and we'll get to them later. So let's get started. Again, here's one of the AIA documents that you need to know about earning the credits, a little bit of our course description here, and again, our learning objectives. And hopefully we'll be able to cover all of these as we go through today's presentation. But first, I'd like to know a little bit about you. So I'm going to ask Marcy to launch our first poll so that you can tell me a little bit more about your profession, and that way it'll help me shape how I talk or some of the things I say today. So polls in progress. Remember to get out of the full screen mode, and you can submit your answer to this poll. And then Marcy, you'll let us know how it looks in about 30 seconds or so. So while you're doing that, a little bit about me. I am a professional forester by training, and I am a professor of forestry here at Clemson University, but I did spend about half my career in the industry, and I've done everything from as a forest geneticist, breeding trees, to working on recycled paper and mill biomass energy and pulp mills and things like that. So done a lot of things around to get to where I am today before I came to Clemson as a professor and a department chair 20 years ago. Marcy? Okay, good. So this is about what it was in our first seminar this morning. So got it?
I'm sorry, go ahead.
Good.
Okay.
We're good. So we've got about...
Go ahead. Can you see it, Pat, or should I go ahead?
Yeah, so we've got about almost 60% of you are engineers, 10% architects, 20% code officials, 3% in the fire service, and then 9% from the other category. So welcome to all of you, and we're delighted to have you today. Let's get going. So when I got involved in this, I'd actually not been a wood products kind of person. In about 2010, our industry looked at me and as the department chair at Clemson and said, hey, you know, we've got all this wood and we've got a great economy in our state, but that we want to bring back after the downturn of the housing crisis, and we want to make sure we have healthy forests. What can you do to help us? And went from a $15 billion industry to a $21 billion industry in our state in the last decade, and we're very excited about that. Our forests are sustainably grown. Our forests are very healthy right this minute in general, as long as we're not in another drought. And we know that wood is a sustainable building material, but not many of our commercial buildings were being built with wood, and we wanted to find new places for that wood to go. And that's how we started our institute. That's why I got involved with it, and I actually joined the institute as director in 2014. There are a lot of new wood products that are coming to the marketplace or being developed for the marketplace, and we feel at Clemson that we help develop southern yellow pine cross-laminated timber, and I'll tell you all about that in a little while in our slides. And we also believe that a lot of these wood products that are available are very compatible with modular or prefabricated construction. And that allows us to build off-site with less weight, to go robotic or to get really innovative, to have our labor sitting in a factory in air-conditioned conditions with all the help they need, rather than being out on a construction site in the middle of winter. And my dad was an electrician. I can tell you that wasn't an easy job. I think he'd much rather have been an electrician in a factory putting in wiring. Excuse me. But so these are all really good advantages why wood is an important place in our system. And it is a green building material. Wood is known to have low embodied energy. It does not take a lot of energy to produce wood when compared to steel or concrete. So it really does not use a lot of fossil energy in the production of a 2x4 or a 2x6. So it's a great material. And as trees grow, they absorb CO2 from the atmosphere and make the product that we call wood. So CO2 and sunlight and water form together to make wood. And that means that wood, no matter where it is always going to be storing CO2 from the atmosphere. So if you're sitting at a wooden desk or you have wooden doors or wooden furniture, you can think about that you're actually storing carbon right there in that wood furniture, desk, whatever. So about half the weight of what you have in your wood in a particular product in your home is carbon. So carbon dioxide stores really well in products that we use. It's a renewable resource. So forests are incredibly resilient and renewable in most cases. And with a little effort, we can make them even better. And that, as a forest geneticist, I was always into let's grow straighter and better trees. So we work to make those renewable resources even better. And they are sustainably grown in the U.S. and Canada. In most cases, our forests are well tended, managed to some extent, protected, and are growing very well. However, and I will say that we could talk about that later, there may be some places in the U.S. or Canada where it's not necessarily so. There may be beetle attacks or something like that. So it will come back, but at the moment, it may not seem to be in the perfect state. And I'll talk about that a little bit later. Wood has excellent strength to weight ratio, and occupants have an affinity to wood. It's designer, contractor, and owner friendly as a building construction material. I will give you a little side note. I heard an architect from the Connecticut area, Yale, talk the other day. His name's Alan Organsky, and Alan was talking about a school that he built. And he was very proud of his building, and it's gorgeous. And he was saying that he talked to the students and he wanted to hear what they thought about his building, and he was hoping it was going to be the play of light on the wood or the neat structure. And what the students said was, well, it smells good. We really like how it smells. And so when we are in a wood building, it really is something to everyone. For those students, it smelled good. For others, it's a sense of peace and calmness. Another architect that I really I think a lot of, he talks about the fact that when he has a wood column in his building, people touch it. He's even seen them hug it. And he said that if he's got in one of his buildings that has concrete or steel, you never see people reach out and touch the part of the building. They don't touch a column. But with wood, they almost feel drawn to touch that wood. So there is something about being in a wood building that makes people feel very comfortable and feel in a very natural environment. So being a forester, I'm going to start with the forestry side of this world. So we're going to talk a little bit about the resources. In North America, we have a lot of forest. And while it's not distributed across every landscape exactly the same, the Southeast, the Pacific Northwest, the Pacific Southwest, the Midwest, the Lake States, even the Northeast, there are adequate and wonderful resources of timber available. There may not always be a sawmill nearby to use that timber, but there is timber growing that could be used. The Pacific Northwest and the Southeastern United States produce a lot of structural timber. And by structural timber, I mean those 2x4s, 2x6s, 2x8s that we use to build buildings. And they are priced fairly well in general, and that sawmills exist to utilize those materials in this area. So we're going to take a look, dive a little deeper, And I'll focus on data from the Southeast because I have that data available and I'm more comfortable talking about it. But the same data could be developed for the Pacific Northwest or other regions of the country. So in the Southeast, from 2007 to 2014, we saw a 3.4% annual increase in the amount of board feet available growing in our forest. So that's the inventory, what's out there growing. That was above and beyond what was lost to death or lost to fire or lost to removal. That's just the standing live trees and what was growing. That's how much we increased in sawtimber inventory. And sawtimber inventory is generally those trees that are, more than 4 inches and 5 inches in diameter, something like that, probably 10 inches in diameter on up. So this is a tremendous increase in a 7-year period of about 80,000 billion board feet of wood. That's a lot of wood. We see when we look at that same 2007 time frame and we put that as a base year and we look at harvest and we look at inventory. So acres is in the dark green, and harvest is in the light green. And you see there's 0 to 0 there in 2007. But as we go away from 2007, the amount of acres goes up. The amount of harvest drops down through the housing crisis, kind of stays stable a year, and then slightly increases over time, but still not very much, while those number of acres are continuing to grow. That's how we're increasing these acres and ages and sizes of trees, the amount of carbon being stored, all of that kind of stuff. And the trend line there shows you that the price is pretty much been going down all that time in that time frame. Not to say that any one price is given. I'm not talking about prices. Just want to give you a trend here. So in South Carolina, we have a very unique, not a very unique situation. I'm not going to say it's unique, but I'm going to explain our situation. So in 1987, and this graph was done with data from 2013, and I'm very comfortable with it, so I'm using this old data. But if we updated it to 2020, you're just going to push those age classes up 2 bars to the right. So what we did was we saw that in 1987 there was a government program, U.S. government program called the Conservation Reserve Program, and it significantly increased the amount of land being planted to trees. This was pulling land from agriculture on erodible sites or deep sands or windblown sites, other kinds of things, land that didn't need to be put in agriculture, didn't need to be used for agriculture, and formally putting them into timberlands. This is the 3rd or 4th time that the USDA has done that, and I'll show you some examples of when they did it in the 30s. This is the example from the 1980s. And then shortly thereafter, in 1989, Hurricane Hugo hit South Carolina, and it devastated a lot of our coastal plain pine plantations. And the data here that I'm showing you is only southern yellow pine. And let me just say that southern yellow pine only occupies about 49% of our state, and only about 25% of our forest land is actually in pine plantations. About 24% of it is in natural pine stands. So you see that after that hurricane, there was another big bump indicated in the 20 to 25 year age class here, where people went back in, site prepped the land that had been devastated by Hurricane Hugo and replanted it to pine plantations to make productive forest. Now, let me just say, in the Southeast, and indeed in a lot of the world, it is the conifers like pines, Douglas fir, that we plant the most. They are pioneer species. They are very well adapted to high light or open scenarios. So if we have an opening in a forest, those pioneer species are the ones that are going to come in first. And this is why when we have an opening, like coming from an ag field to a forest, pines may be the optimum product, the optimum seedling to plant, and they are planted very easily, and we know how to grow them in nurseries and plant them very easily. But if you do nothing to those pine plantations, they will eventually, in some cases, not in many cases, be replaced with either a mixed pine hardwood stand or eventually a hardwood stand in subsequent successions. But in this case, we're looking at what they look like right now, and that succession may take hundreds of years. So here we go. So a lot of people are always worried about, are our forests sustainable, are our forests healthy? And a healthy forest are often seen as, or unhealthy forests, such as with bug damage or overcrowding, are often seen as a problem for wildfires, especially very destructive wildfires of the West Coast or even the Rocky Mountain area. And here, even in the Southeast, if we have unhealthy forest or overstocked forests, we may be more susceptible to all kinds of problems. So we do understand how to be sustainable and have healthy forests. And one of the things we find is that when we have an active forest market, a place for our landowners to sell their trees or products from their forest, then we will more likely have well-managed forest in that area. And therefore, that circle of forest markets and healthy forest is one that is very important. And in fact, data has shown that where we have a good forest market, whether it be a sawmill, a plywood mill, or a pulp mill, the forest surrounding those mills and operations actually increases the number and amount of trees and wood being grown in that area, and we get more healthy, well-managed forest in those areas. Now, we're going to talk about mass timber today, and I'm going to tell you that we're in an early state, and while they are one of the things that we can use to increase markets and to have more healthy forest, they are not today a silver bullet. Nothing is a silver bullet, I think, when it comes to climate change. But certainly, the things we're going to talk about have a role, have a way to play, a contribution to be made, and I hope that you'll get that at the end of our talk today. So a lot of people are worried about very small diameter woods. I've learned that small diameter wood is in the eye of the beholder. To me, a small diameter piece of wood, tree is less than 6 inches. To some people, it's less than 18 inches. But I will tell you that most modern sawmills, modern efficient sawmills in the United States, and that's like better than 85 to 90% of those modern efficient sawmills that are going in today, are not going to be able to take wood that's bigger than 28 inches at the biggest end of a log. So we're not cutting really, really large trees anymore in vast quantities. So it's really coming from that middle-aged kind of tree that we're really concerned with. So we can talk about that later at the question and answer if you want to talk about it. But it is actively, the most wood is coming from really well-managed forests, be they natural or planted, and growing under an active management system. So let's ask our next poll. Do you have concerns about the sustainability of wood for mass timber? Marcy?
There we go. So people have started voting, and it's fun to kind of watch the numbers come in. It usually leans heavily toward one answer, and then it kind of shifts a little bit. So, but of course you all can't see what I see. So, all right. Well, I'm going to go ahead and close, and then you can see the answer or see the final result. So, we've got 64% say no, they do not have concerns, and 36% say yes. So,
Okay.
Yeah.
Good. That's good. So is this my next slide? Yes. So this was, I'm a big devotee of Twitter, which is really terrible, and it got it, and I got addicted for football, so we're just going to have to excuse me for that. But I was on a Twitter site that I read out of the UK. After I had a trip to the UK, I started following some of their forestry Twitter sites, tweeting sites. And this one came up and it said, "This is not a forest." That was the title under this picture. I found the picture. It didn't give the citation in the Twitter account, but this is a pine plantation, and it was posted in a UK website saying, "This is not a forest." And I wrote back immediately appalled and said, "This is a forest. It's just a forest that needs thinning." Because when I see this forest, I know that the next step of this forest is something that looks like this. That we have to get through those gangly teenage years of forest to get to beautiful mature forests like this. Now, this forest probably started out, could have started out as a natural regenerated forest or a pine plantation, but with good practices of management and thinning and prescribed fire, which I know this one uses, we get to a stand that looks like this. And this is a stand that has great habitat. It has a very rich, diverse set of plants and animals that use this site. And probably right there at the bottom of that picture, if you can see it, there are probably 100 different plants in a square meter of that site right there. A very diverse site and very beautiful forest. So from here to here, and it's really all about the management that you do on the forest. So here are some examples of differently managed forest. The one on the right, up top left, is the Clemson Experimental Forest. This forest has a lot of prescribed fire in the half of the forest that is pine. About half our forest is hardwood, and about half our forest is pine. And we use prescribed fire to get rid of debris, of invasive species, and of species that we don't want in our forest because we're concentrating on pine. If we wanted to convert this stand to a mixed hardwood pine stand, or especially mixed pine oak, there are some oak seedlings in there that the fire is not going to damage so much, but it will take out maples, sweet gums, and other species that might not be the ones that we want to manage. So the tool of fire is one way of doing a lot of things in a forest that we can accomplish at a very reasonable cost. It is an alternative, or the alternative to that may be either mastication using machinery or to use herbicides to get the same effect. But our species in the United States, many forests in the United States were ecologically developed, or the ecosystem was developed in which fire played an important role. And this was certainly the case here in South Carolina. We know that for the last 30,000 or so years that human intervention on the landscape included the use of fire. And so our ecosystems were developed under that. And we have some beautiful wildfire flowers that we know are here that are actually endangered, that we have to use fire in order to get these wildflowers to actually have seed and to come back every year as an annual plant or as a perennial plant. We can use thinning also, and site preparation and other factors. The stand that you see on the bottom is from one of our American tree farmers who was a National Tree Farmer of the Year. I was very fortunate to go on a tour last August at his house, and Gail and Skeet Burris, so their names. And Skeet has timber because he wants to have timber and make money off from it, but he loves to hunt, he loves to fish, and he has a lot of recreation time with his family. So you can see that he has a pond that he created. He's planted both mass trees as well as fruit trees along the edges of his forest and his ponds. And then he has his pine plantation in the back, and I believe this pine plantation has been thinned twice already. The Burrises do a beautiful job of forest management on their pine plantations, and their overall landscape is just delightful to be in. It's a mix and it makes you aware of how beautiful nature is if you ever have an opportunity to visit a stand or a forest landowner like Dr. Burris or any of the many colleagues that he has and many landowners that we know. There's a beauty, and every one of these pieces of property in and around him can be managed differently to accomplish the landowner objectives. If the landowner is not worried about hunting or water or fishing, he may just manage for timber. But if hunting is more important or recreation is more important, it may be something totally different. Same mixture of species, same types of techniques, just knowing how you get it, knowing what you do, and when you do it, you get different outcomes. And that's what foresters are actually supposed to be able to do. And hopefully all of our students are doing this very well out in the field. But every forest is unique in terms of what you want the outcome and what inputs you put into it, but good techniques result in good forests. So I wanted to give you an example of a non-plantation. So this is kind of an uneven age forest. It is a mixed pine hardwood forest. You could find this forest anywhere on the East Coast, and there are resemblances of this forest in other parts of the country where you have stands that have different age classes, different species types, and these two can be managed, and there is a technique and a thought to how you manage and how you get back the certain species you want even without planting, because with uneven age forests you may only harvest in groups or selects, and you want to make sure that you're always growing the right species and mix of things that you want to do. So there is management to even accomplishing what we're doing here. So I'd like to talk a little bit about change in the U.S. South and indeed parts of the U.S. in total by using an example from right here in Clemson. We have a 17,000 acre Clemson experimental forest, and the area was settled in the late 1700s, and it was farmed, from everywhere you could see. And so our first example here is what that farming looked like around the early 1900s. These were subsistence farmers to a certain extent. This is cotton growing right up to the edge of the house and right out the other side of the house. And cotton was grown here later in the early 1918, 20, we got boll weevils, cotton prices dropped, people abandoned their farmland, but by then the farmland had been, the topsoil had washed away, the nutrients had gone, and farming was just not very prohibitive. And so on this soil, which is some of the most erosive soils in the world, it looked like this. And I can walk across my campus and see ravines that look like this today that have never filled in. And in fact, right near my office, there is one that's more than 3 times my height. If I go down to the bottom and look up, it's 3 to 4 times my height in depth as a ravine. It's a great example for us to understand that we have to be respectful of soil and understand how to use it. And so during the 1930s, under the WPA and the Civilian Conservation Corps, and under the Bankhead Jones Farm Tenant Act, this land was purchased from local farmers and put together as the Clemson Experimental Forest. And we started replanting. We rebuilt recreation areas. We actually restored fish to streams because there was a series of fish hatcheries here to reestablish populations of fish because the streams are so polluted and silted in that we had to stop the erosion, then get the water clear again and get those fish back in the system. But this is what the work that happened from about 1938 up until this picture, which is in the early 1950s or late 1940s, and these are all from the Clemson Experimental Forest Archives, by the way. These photographs show, this photograph shows one of our forestry extension professors going out to measure a plot where we were learning about, could we plant trees, how fast would they grow, how far apart, how many trees per acre, how did the litter layer, the pine needles fall, did it help the soil? Lots of research went on in those early time periods. And today, that same area looks a lot like this, and that's not the original forest that you saw on the previous photograph. This is the second pine forest that's been grown here, and it's doing very well, even though with me, I'd like to see a prescribed fire, but I know that there's a lot of grapevine and black briars or blackberry briars out there that all my wildlife habitat is really key to. So it's a well-managed forest now, and still a managed forest in which we use harvest and regeneration as a tool to keep a very sustainable, healthy forest going. So changing subjects a little bit, but not quite, because we want to make sure that our forest is well managed. We started having our forest grown to a standard, and at first it was under the American Tree Farm System, but it's fairly large, and so we eventually decided to use the Sustainable Forestry Initiative standard, which is an audited standard. So they come in every so many years and they audit our practices and what we've been doing. And to this standard, the Forest Stewardship Council also has a standard for well-managed forest. And then there is a global standard, the PEFC system, and Sustainable Forestry Initiative and American Tree Farm System, I know, are part of PEFC. Forest Stewardship Council is its own global system. But those standards are out there so that landowners can manage their forest according to the standard of practice that are outlined in these standards, and feel and that the people who buy their trees or use their wood can feel that there's some assurance that that it's well managed and taken care of. And this links to chain of custody so that you can even find out which pieces of wood came through to a sawmill and then into a product, and even into the mass timber. If you're buying mass timber, some of these are now chain of custody satisfied. I do want to go back, however, and mention lumber standards. Apologize for that quick finger on the standard there. When we cut wood or cut logs from our timberlands, and we go to a sawmill or a plywood mill or some other manufacturing site, there are regional and species groups of standards. So, for example, all hardwoods are under the National Hardwood Lumber Association standard for grading the pieces of wood that are produced and go to market. And they train the people who grade the wood or set up the systems for doing that. Southern yellow pine is one species group, which is the standard is developed by the Southern Pine Inspection Bureau. There's a Western Inspection Bureau, and there are other inspection bureaus to different regions and different species groups. So Southern yellow pine is not the same as Douglas fir, which is not the same as spruce pine fir or hem fir, and there may be standards for each. There are standards for each of those groups. So if you go to Lowe's or Home Depot, you will pick up a piece of wood that has been graded to meet a certain standard. In the softwood species that we use for construction and structural strength, we find that those are often machine rated kind of stresses and strains, so that we can be assured that it's going to hold what we need it to hold, or be able to be used the way we need it to be used. I will say that knots and other things are and curves, crooks, checks, things like that in the wood are some that degrade the wood so that we're not getting prime wood. Not every log gives you prime wood. Not every piece of wood from every log is the same. So it varies. So within a log, if we cut it at a sawmill, we'd have a variety of different strengths, characteristics, and grades of wood coming from that. Now, let's move into the building world, and we also have standards, and those are our building codes. And so building codes have been very important in the wood industry, and especially in mass timber. The 2015 was a breakthrough code for us. Prior to that, there had been heavy timber codes, or heavy timber was mentioned and light frame was mentioned. But in 2015, we introduced cross-laminated timber, which is one very important source of mass timber. And it can be used in both Type 3 and Type 4 buildings. In 2018, the building code that came out expanded the use of mass timber and expanded the use of cross-laminated timber. And then coming up in 2021, work has proceeded so that within that printed code, when it comes out, there is now a mass timber section that introduces Type 4A, Type 4B, Type 4C, alongside the Type 4 HT, which is the old Type 4 building for heavy timber. We're now introducing these mass timber sizes and sections, and they allow you to build up to 18 stories and different sizes depending on what you're doing, how much have to be covered to meet fire standards, different areas. And so these are the brand new Type 4s that we will be coming out. So here's the next poll. Which building code is being used in your jurisdiction or location? Marcy?
Yes, indeed. So I've got it up, so everybody can start voting. And 2012, 2015, 2018, or other. So,
I will say while we're waiting that in some places, the 2021 mass timber section has been added to one of the earlier codes acceptable. So there's a couple of states that are stepping forward and actually taking that section out of 2021 and putting it in place already. So.
Excellent. All right, so I'm going to go ahead. I've got 80%. Okay, 44% say 2015 codes, 2018 codes 42%, and then just a few people for 2012 and other codes. So.
Okay, 2012 users, we got to go for it. We got to get that 2018 code or the 2021 code in. Come on, pull it. We got to get that done. Ask your building codes people to do that. So get back to my system here. Okay, so I want to talk a little bit about buildings with wood. So wood is a very old building material. We've used it, and we've used it well for many, many, many thousands of years. And in case you didn't believe that, I brought this picture from China. It is a temple that was built in 1056 AD, so it's almost 1,000 years old. And it was built, and it is taller than 220 feet tall. I'm not sure the exact height, but I know it's a few feet over 220 feet tall. Now, good maintenance and taking care of buildings and excellent building quality and craftsmanship, this building is doing very well. I actually went to China last summer, and I actually got to see the Forbidden City and all of that. It was built, I think, after this, but it was all gorgeous and built with a lot of heavy timber. It's really beautiful when you go to see these buildings. But here in the United States, we were building tall buildings with wood, but they were heavy timber buildings, and this is one of the early ones, not as tall as some of the others, but this is the Bradbury building, and this is a heavy timber building and I think this was in Los Angeles. So just an example of where you can see that. So I want to make sure that if we have it, or if you have it, if you guys will let me know if you have built with either light frame or heavy timber buildings before, or if you've been more steel and concrete in your building backgrounds. So can we launch this poll real quick?
We certainly can. So if I can find my mouse, there we go. So have you been involved with light frame or heavy timber buildings before? Okay, and I have 30 seconds and 80%, so that's awesome. And it looks like the majority of folks have been involved with light frame or heavy timber buildings. So 85% say yes and 15% no.
Okay, great. Wonderful. That's good. Really exciting to hear that. So I want to turn now and talk about mass timber building systems. And while there are individual products that make up mass timber, I think the beauty of it is the system that we use to build with it that really brings it to light and gives it a lot of the advantages that are going to make, I think, this type of building become a predominant type of building in the next 10 to 15 years, or at least I hope so. So these are two examples. The one on your left is the building we were doing here in Clemson, South Carolina. It's an outdoor recreation building, so our kids who want to go camping, hiking, biking can come there and get materials and check out bikes and stuff like that. That large structure in the middle is a 2-story elevator shaft made out of 5-ply CLT, and this is Southern Yellow Pine CLT and Glulam. So we're very proud of this building. It is a hybrid. It does use steel poles to hold the Glulam, but with that, we were able to open up an atrium area and to have our Glulam beams stretch over 80 feet for their upper story and our lower story, so that it really is a gorgeous building with lots of room and lots of openness. And our CLT is used as exposed CLT in this building. And I'll show you more about what that looks like in a little bit when we'll show you a picture of how it went. The building on the right is one of the early buildings that was built in Canada. It is the University of Vancouver, and is their geosciences building. And you can see the tall Glulam columns and then the floors and the cross section there and the glass wall. But I think the most impressive piece about this is the gorgeous staircase that was engineered and designed and which basically has nothing to support it other than where it attaches to the floors. And it is a beautiful staircase. You feel like you're walking out into air. The story is that the first person who actually went out and walked on it after they got it installed, they actually put a structure around him such that, in other words, he had like a climbing gear on so that if he stepped off and it fell, or didn't work, they could catch him. So, but fortunately, it worked beautifully. And if you ever get a chance to go to the Vancouver and visit the University of British Columbia, UBC in Vancouver, take a chance to go into this building and see how it is. It's very breathtaking, especially if you're up top in the building and looking out across the campus through the atrium glass windows and stuff. It's a gorgeous building. So mass timber that we're going to use today and talk about in our discussion today, I've mentioned cross-laminated timber. We're going to look at nail laminated timber, dowel laminated timber, and Glulam. There are a few other types, but I'm not going to try to go through all of those today. That's for another time and place. But these are predominantly the 4 that are used that have been used most often in buildings in the United States today. So this is cross-laminated timber. The piece you're looking at is a 5-ply floor plate or ceiling for the floor below it. It was produced in Quebec by Nordique, this panel was. And it is it's being lifted and laying into place over the walls, and the walls below are 3-ply CLT panels that are standing straight up. So they lift into place, and again, if you look at the 5-ply one, you can see that you go long section and then you go crosswise with a section of wood, and then you go long, and then you go cross, and then you go long. So with that crossing of the different layers of wood, similar to what we would call plywood, how plywood is manufactured, we get incredible strength in 2 directions as we utilize that wood in the building construction. So it gives us the strength in two directions, which is really remarkable and exciting for us as we look forward and start building with this. Now, nail laminated timber, or as some building codes call it, mechanical laminated timber, are actually just 2x4s and 2x6s or 2x8s laid on a side and nailed together. This is a very, very old type of building material, and many old manufacturing sites, mills, old heavy timber buildings, the floors of those buildings were built out of nail laminated timber. This type of mass timber only has strength in one direction. So it does not have the cross-directional strength of the CLT. Since this uses metal nails, steel, iron, whatever nails are made out of these days, when you put those nails in, it also means that if you need to cut a hole, you're likely to hit a nail, and that might damage your equipment in the field. So again, it's really important to think ahead of time about where you might want to put a hole and just gauge it in there. So really building around things is really important. You'll see in the picture on the right, which is from the T3 building in Minneapolis, the floor panels are much longer on one side, and where they needed to stop it, they just had to nail shorter pieces of wood together and build that structure on the ground beside the building and then lift it into place. So it does make a difference on that. This is DLT, or dowel laminated timber. It's very similar to nail laminated timber, but instead of using metal nails, you use wooden dowels. And so I always wanted to know how things work. Figured it out. They use a hardwood round dowel that they heat and dry to a very, very low moisture content, like 3% moisture content. Meanwhile, your 2x6s or 2x8s or whatever you're using here is dry to it where it needs to be, and then they run a hole through it, drill a hole through it. They have sized the hardwood dowel that it's smaller than that hole, just slightly, so it fits in, and then they allow the wood to all come back to the relative humidity of exposed in the building itself. And as that happens, that wooden dowel absorbs moisture and swells. And as it swells, it fits exactly to the dimensions of the hole and the softwood lumber that you're using this in, and it will not move. So there is no glue in this. But again, you only have strength in one direction. There is no overlapping strength. And because there is no glue in either nail laminated or dowel laminated timber, you also may get shrinking and swelling of those individual pieces of wood. And so you may have to leave spaces between certain areas or every so many feet so that the wood can slightly shrink and swell. If not, it may cause problems with your construction. Glulam beams, finally. Glulam are beautiful beams made out of wood. This is the Raleigh-Durham Airport, and an airport can be very cold and sterile, especially with just steel and concrete. But when you add this dynamic of these large, sweeping, curved Glulam beams, it makes the whole room pop, in my opinion, and it feels warmer and more comfortable and more earthy somehow or another. So I like this look. And I think Glulam was a substantial opportunity. We use Glulam beams a lot in commodities as headers and light frame construction, but there are types of beams that look just like this that they're frankly architectural grade, built for beauty and strength, and we have the capability with Glulam to do that, to build for beauty and strength, and to curve and to do all kinds of things with it. So mass timber, of course, as heavy timber was very popular 100, 150 years ago. Heavy timber also is considered sort of the residential log cabin kind of thing. That's still been going on in a certain area, but not really entering the commercial building sector or where we'd love to see it enter. And so mass timber, the cross-laminated timber, was developed in Europe, Austria, Germany in the early 1990s. and it was tested and used there. And then it came over to North America. I will say that the picture on the right is a underside of a house that was built at Hilton Head, South Carolina in 2010. It is a steel steel beams with concrete columns to hold up this house because it is a beachfront, Atlantic Ocean front house. And then they used CLT floors above that to build this building. So we've come from 2010, when there was one house or maybe two houses, depending on the count, and I don't have that, to a lot more, and I'll show you the number we have now. But before I do that, I want to pay a little tribute to my favorite architects, and I've told this story a number of times. When I was a teenager, I had the Monkees and Paul Revere and the Raider pictures on my wall. If I were a teenager today, it might be these people. These are some of my favorite architects, and they've really worked very hard to bring mass timber buildings to the forefront and to bring attention and to drive forward these. And in fact, Susan Jones shows here on the lower left was a part of the building code team that was put together to develop the mass timber building code. So really worked hard to bring this. And these are their buildings. So Andrew Waugh built that 10-story Murray Grove building in London, and it opened up, and it was the first big high-rise in the world. Then Michael Green built the T3 building here on the right, upper right, in Minneapolis. Susan, this is the inside of a church. This was an old manufacturing plant, and they redesigned it, and she used sweeping tall CLT beams, panels that were cut in extreme angles, and the light and the play there is just gorgeous. That is a light colored wood and just beautifully done in that church. And then Thomas Robinson did, he does a lot of work in Portland. This is one that I've walked by and took this and tried to get a picture of it, but it's usually not pretty when I'm in Portland for some reason. But this is an example of his building. And then Tom Chung did the building on the lower right, excuse me. And that's the University of Massachusetts at Amherst School of Design, and an incredible building utilizing a lot of wood and a lot of incredible design. Believe it or not, that building was actually designed originally to be done in steel. And they went into it and said, hey, what would happen if we changed it to wood? And they were able to do that. And it was an incredible design and an incredible building. And all of these architects are still continuing to design and build in mass timber. So where would I want to use CLT in mass timber? Well, there are a lot of places, just for the beauty of it, for one, or when it is meets your cost constraints or meets your cost initiatives, or is the low cost option. That's always a time to use it. But there are a couple of times when it's really, really important. And when you get 3 or 4 of these conditions, you really need to just go straight to mass timber. And that's when you have high labor cost or labor scarcity, and there is that in many cases, a poor soil or high foundation costs. Schedule constraints is another time. I also would add to this that if you have a very small footprint in which to build a building and no room for waste and layout and all kinds of things, you can do it with mass timber, because you can bring in on trucks exactly what you need and have a lot of things on a truck and build it, lift straight off the truck and into the building site. So if you're in an inner city, this makes a lot of sense to move into a mass timber system. So really a great opportunity for all of these. I'm going to add one more though. If you're ever building in a university and we're trying to teach classes, please don't use big pounding noises to get your your foundations in. We really would love quiet foundations, and CLT has the quietest foundations I think you can use. So I really wish that when we were building a building we did on our campus about 8 years ago, I thought I was going to have migraines every day because it was pound, pound, pound to drive poles or foundations into the ground, and I think all of us were about to go crazy there. So mass timber products are made in North America. I'm not showing the Canadian producers because it's hard to get them all on one map. You can't see them that way. So I'm highlighting the ones in the United States. There are a few on the West Coast right above Vaughan and Gatera. There's Structure Lamb and Kalishnikov that have just opened up, and then the Dow laminated timber product is also in British Columbia. I'm not going to get it. Structurecraft. They are also in British Columbia. And then Smart Lamb, Alabama, and then Smart Lamb or Structure Lamb, which is from British Columbia, is about to open a project, a manufacturing plant in Arkansas. And then in Quebec, you have a few, in Ontario, a few other producers that can feed into the Northeast, including Nordique out of Quebec. And so the Sterling and Texas CLT, the 3 plants there are all utility mat manufacturing plants. They are not certified to the PRG 320, which is a manufacturing standard to make building products. So they do make utility mats at those processes and systems. So moving on. Oh, by the way, I will say that there are at least 3 and possibly 4 manufacturers of mass timber, including Glulam and CLT, in Europe that are producing and exporting into the U.S. And they are doing it by shipping over ocean freight, and it works very well for them. And if you put something on a ship, it doesn't use a lot of energy to produce it and move it. So transportation-wise, if you're worried about fossil transportation fuels or pollution, they can get it to the East Coast fairly simply. So these are the buildings that are currently in design stage right at this moment. We have over 700 buildings that are either in design, the construction has started, or they're already built. Now, these were done by Woodworks and do not necessarily include some of the residences that are out there that I know about. Like, I don't think the Hilton Head system is in this one, but they are ones that Woodworks participated in or knew about, and they're gathering this data up and utilizing it. And you can see that there are clusters in the Pacific Northwest, Texas, right in the Southeast, another big cluster up the East Coast, Mid-Atlantic states into New York. And then a larger number, or some growing, there's a McDonald's in Chicago that is made out of mass timber. So amazing that these buildings are going in and starting up. And if you just Google CLT buildings or Glulam buildings or something like that, and or if you're following social media, there's a new building almost every week that you can see something going up. As I said, we have one here that we just finished. We have one that we're starting construction on at Clemson. Wofford College has another one. There's another one that just won a regional wood design award in Lake City, South Carolina. And then more that we know are in the pipeline coming up. So even little old South Carolina has some going. So I'm going to quickly ask, have you visited a mass timber building? Marcy, thank you.
Sure thing. So just quickly let us know. All right, I'm going to go ahead and close and then share the answer. So we've got about 56% say that they have not, and 44% say they have visited.
Okay. Wonderful. If you have not visited a building, I encourage you to do so. It's quite an experience. While some of them are not open to the public, others of them are. If Clemson opens up again and we start having our buildings, we hope to be open again by fall semester. If you're in this area, please let me know. I'd love to show you around one of our buildings and maybe even show you the construction of a building on our campus. But it is a unique and different feeling when you go into these buildings. So it makes it's interesting. So the picture here on the right, no, on the left, I'm sorry, the left, is an early high-rise. It's one of the Butler Brothers buildings that was built as a warehouse. It's been reconfigured in Minneapolis and is actively being used. This building was built very, very strong. I think it's 150 PSI or something like that. Rated, and that is a glider hanging in the middle of it. So when they remodeled it and opened it up, they were able to put a glider into it and hang it up. And I've seen different other things hung from that ceiling in various photographs. But the building's very inviting and well used. Nearby, Hines Development Corporation was looking to build a new office building in Minneapolis, and they found that there was, near the site that they own, there was an old heavy timber building, not necessarily the best maintained building in town, but it always had occupants, and it always had a waiting list of people to move into the building. So Hines, being the savvy office owners and developers that they are, said, well, we don't deal with renovation. We're not going to renovate. That's not their style. That's not their mode of operation. And so they said, well, how do we best imitate that feeling of being in a heavy timber building that people like, obviously, because they have a high rental rate and a high occupancy rate and always a waiting list. How can we put that in a new modern building? And so Michael Green Architecture designed this building, and it is, I've shown you the one picture of the interior of it before. It is post and beam, glue-lams with nail laminated floors. And they've since opened another one of these buildings, but with a different exterior covering, very similar, in downtown Atlanta, and it has dowel laminated flooring in it. But Hines is very excited. They have 5 or more in production already to be built, or about to start construction, already under construction already, and more planned. They feel that this is just a wonderful feel of a building. Their clients, their tenants like the buildings they're in, and they're well designed and well made. But what else can mass timber do? So here are some examples that we're going to quickly run through. This is a bridge. This is supplied by Nordique. Nordique lives in and works out of northern Quebec, and they have had to build bridges in order to get to forest operations or to have their employees get to work. And so they've used glulam and mass timber to do it. So the structure on the right, if you see the one where the holes cut out of it, those are cross-laminated beams, panels, and then the beams, of course, are glulam beams. So they do a very good job of that. These are utility mats, big use in the oil and gas and construction industry. If you're putting down something that on poor soil and you need it, like a lift truck or a crane, or even heavy equipment needs to get to a muddy site, these utility mats are laid down like a road or like a platform, and they're used and reused, picked up, used again in another location, and are very, very excellent mats and well used. And like I say, there's such a need for them that there are 3 plants that have been built and are manufacturing these just for utility mats out of cross-laminated timber. Barns and factories. This is a manufacturing site. Looks like it could be a barn if you needed it to be. This is in Rockwood, Tennessee, and this is Souter Timber Company, and they actually buy panels from Europe that are CLT panels, and then saw them to design needs in their own factory here after it was finished, and they are building houses and buildings all over, and have now opened up an operation in California also to do the same thing. You can build tall buildings like the University of British Columbia in Vancouver's Brock Commons, which is a 18-story building on a cement podium with concrete podium and concrete stair and elevator shaft for strength. Short buildings. This is a soccer stadium that was being built in Austria when I visited with the manufacturer there. So doesn't have to be big. And then massive buildings. This is the Zurich Zoo in Switzerland. And you can find here the elephant. Let me go back and show you the elephant. The elephant is right here in the lower middle of the picture. By the way, I did want to point out, a lot of people are wondering about why don't we do this with hardwood. This building is hardwood. The development of a manufacturer using European beech, which is what this is made out of, does exist in Europe. It does not exist here in the U.S. And there are some steps that we all have to get through in order to have a hardwood manufacturer of CLT, but this is one of them and a beautiful use of European beech. Speedy construction, you can see that elevator shafts can go up this way or they can go up partially with you one way or the other, but the building goes up very quickly and you can do about a floor every 2 weeks for certain, maybe less if everything's working right and the weather cooperates. By the way, I always get questions, well, what about when it gets rained on? Yes, we know it's going to get rained on, and in fact, they built one of these hotels in New York and it got snowed on almost every day, and they would have to get the snow off. But because these are dried and then glued, and they're very consistent, if you dry out the wood, squeegee it off or just keep the building open a little while until you can get the dryness you need, you do not have moisture problems during the construction, and it's okay to build. The only time when it's difficult to build is with high winds. So if you're trying to lift a panel that is a large flat panel and you've got high winds, you can't control the crane very easily. So the only weather constraint that's going to hold you back is high wind. And we've done a lot of research on these buildings and on these types of products. Now, of course, Glulam beams are a very old product. They've been in the United States and manufactured from southern pine for probably almost 100 years, and other species also. But one of the things, if you've got wood floors in your house, you know, you can hear people walking across it, or feel the vibration in the motion. So we really wanted to understand about vibration. So this is a 40-foot long panel, and it was held up at each end, so it was a 40-foot span, and you can bounce on this to a certain extent. But we were just looking for simple vibrations of a footfall, and we have to take into account that and understand how to design around it so we don't get an uncomfortable vibration in the floor for each building use. And there are building codes and design standards about vibration, so we know how to do that. There are also acoustic standards that we have to use, and this wood often needs an acoustic mat and a concrete topping on it to prevent vibration and sound from penetrating. So that is taken care of in some of the design standards if you're ever building with these. Just be aware. This is some work that we're doing because we live in a tornado and hurricane system, weather system, and this is an example of a 15-pound 2x4 being shot at about 80 miles an hour out of an air cannon to see how much damage you could get or what happens when something like that hits one of these wood panels. This is a 3-ply panel that we were working with, and I think we tested up to 100 miles an hour or whatever there is a standard for how you test for impact testing. So we've just had a PhD finish his research on this impact testing, and it's really interesting to watch because it is such an elastic system in the middle. You get a lot of movement in the middle, but at the edges of the panels where you're connecting them together, it's a very stiff system. So really understanding that total model of how you put things together and what your impacts are going to be is one of the study. So you'll be seeing more coming out later as a result of that work in the engineering journals and stuff over the next 6 months, we hope. Another thing, if you're going to build tall, you've got to build with wind issues, and so steel, concrete, all tall buildings have to deal with what's the effect of wind. So we actually have a student here at Clemson that's looking at what do we deal with on wind, and this diagram, if it's not jumping around too much, just as an example of how you model winds and wind systems in wood buildings. Another thing that we're doing is we have all these panels and they're coming together and they have to be connected, and so they have to be turned into diaphragms or large systems that we'd like to act in composite action. And so we'd like to know how stresses and strains affect these diaphragms. And so this is the beginning of a test that we did on a diaphragm of 5 by 10 foot panels that were put together for a 6-panel grid of CLT, and we did this test early, and we're going to be publishing on this. And then we were looking at unique connection systems here. We have about 3 more of these tests that we're going to be doing with different types of connections. Currently, connections include, when you're putting these together, is you basically create a slot on each side of the panel that is about an inch deep, and you lay the panels down together, and then you put strips of plywood down to fill the hole, and you screw through the plywood into the panel itself. And so using that plywood connector on top and the screws down through there, that's how they've been connecting these before. You can see some straps that might be used, some other techniques, and these are things that we're developing, designing, and working with manufacturers on. How do we best connect these large panels of wood together? Now, of course, everybody's interested in moisture. So the building at Clemson, as well as Brock Commons, Carbon 12, and a few other buildings across, I think the University of Arkansas and some others, are part of a moisture sensor test that's going on across Canada and the U.S. And so our building has a boat shed, which has exposed roof of CLT with glulam beams. So we are testing at 1 inch, 2 inch, and 3 inch depths for the moisture that's going to be in those levels of wood from just being exposed to nature. So this is not the interior of a building. This is a building that is open to the air, and so this is one we're looking at. We do have some of the same sensors within the actual building itself, so they're all in a monitoring system, and these will be used to fill in. On the right here, the little black thing in the ceiling here is an accelerometer to test vibrations. So the room above can be used for exercise or classes or a meeting space. So we're going to be looking at the accelerometer to see if we can tell any difference between uses and any vibration at all that might come through from the floor above to this ceiling. Other partners have gone together to produce blast testing results. So the DoD originally required blast testing on all of our buildings on DoD bases. So I hope that you can see the blast going off. Just to give you an example, they did test this system. They used, I think, 3 different levels of TNT to do this. This was done at Tyndall Air Force Base, and these views or videos, if you want to go look at them, are on the AWC website. And if you look up close, you can actually see the building move. And in and out, and they did actually take them down, repair them, or not take them down, but pull out any damaged pieces and repair them. So we did look at, yes, if there is damage to a building, you can pull out a panel and repair it in some situations. So it may be that we're going to be thinking about deconstruction and reuse of some of these buildings way into the future if we're going to, instead of just discarding wood from a building, how do we reuse or remanufacture or recycle that wood in the system? Another big interesting piece, because as you know, there's a big area of wood buildings in the PNW and in the West Coast, and so seismic testing was also a big portion of this. I'm going to show you just a minute of this. I'm going to be quiet because the sound on this is going to show up. So here you go. And if this is not doing, hopefully we'll just get a little of it.
It's not streaming.
Okay, then I'll stop it immediately. And we'll look that you can see in this picture that they did shake it up to the 7.4 earthquake, which is the Northridge earthquake in California. And we were looking at different tests on this, so there were different connections and different types of construction that were used, and they're evaluating it. Just want to put in a plug that there is a 10-story shake table test coming up in the next year. So hopefully in 2021 we'll be building a 20-story test or 10-story building on that, and shaking it also. Again, everything that is coming out in mass timber and going into building codes is being tested very rigorously and with a lot of cooperation to make this happen. Now, when I first asked a group of my students if they would live in an 18-story building made of wood, they immediately said, no, we'd be scared of fire, and they're foresters. So I think it's important for us to all step back and think, and I know there's several fire code officials and fire marshals on this today, but we know that wood is combustible and that other building materials aren't combustible. But some of those building materials that are not combustible are not fire resistant, where wood, while it is combustible, is very fire resistant, especially in large sizes. And so as we developed and built some of these cross-laminated timber panels, it was important for us and developed the mass timber building system. It was important for us to test for fire. So this was the base compartment where everything is encapsulated. Everything has chipboard over it. The interior has got a lot of measurement sensors and things like this. It's fully loaded with wooden furniture, and there's extra wood in here to be sure that there is plenty of fuel here for this fire to take place. They set the ignition on this, and 3 hours later, this is what we got shortly after 3 hours. And so the fire did put itself out without sprinklers, even with these large openings. Now, if you were in a normal building and the room was closed off, you'd never have enough oxygen to ever burn this much, unless the windows exploded or something. But we wanted to give it the most extreme conditions we could. There's been a test here. The one that I'm showing you now was done at the Alcohol, Tobacco, and Firearms Labs. There was also some testing done at the National Institute of Standards and Technology, and then there have been similar tests in countries around the world. Canada has done some fire testing, and not only are we doing compartment fire testing, we also do a lot of fire testing on just connections of where two beams combine, what those tests are. So there's been a lot of testing on this that is available. Videos are available in lots of places, but if you would like to read more about this and about the fire resistance of wood, it's really important. I was very happy that I was able to visit Nottingham in England, and I met with their fire department. They were in the middle of building a mass timber building at the University of Nottingham, and during construction, it unfortunately caught fire. And because it was under construction, there's a let burn policy, so they let it burn. But I did go meet the fire service, and I talked to them, and they said that based on the experience post-fire, that they would have felt more comfortable going into this building, because after the building had burned, there was still structure during the burning that would hold up a fireman if he had to enter to save someone. Whereas in other cases, if you have metal, you use the strength, that they're not fire resistant, and that strength goes away in hot fires, and you wouldn't feel safe walking on a floor of metal in a burning building. So it was quite interesting to me. I'd never thought about any of those things before, but I've learned a lot since I started working on this. So Are any of you currently working on design or construction of a mass timber building? Potentially maybe even in coding or the codes work for a building of this type?
All right, I'm going to go ahead and close since we are quickly going ahead and getting close to the half hour, but let's see what we've got. We've got 90% say that they have not and 10% have, so, or are, I should say. So.
Wonderful. Well, I would encourage all of you, if you get an opportunity and a building is going on and an owner is interested in it, there are lots of opportunities for help and in the engineering or design that's free to you, and Marcy will tell you about those, or Michelle, at the end of our talk today. But I encourage you to reach out, contact. There's all kinds of materials online. Don't be afraid of this. Your first building, you sort of choke on, but I didn't. I had a great team here when we were building this one with Clemson, and they feel like they had me as a team member too, because I tried to bring all my wood knowledge and what I knew to a company that had really not ever done a mass timber construction project before, and a university owner who'd never done one of these before. I mean, we had heavy timber, but none of those people are alive now. So it was really exciting to put this together and really come up with our building that we absolutely adore. And everyone who's gone in it so far has come out saying, wow, I want to move here. I want my office to be here. I'd love to be here. Now, this is on a lake, and it is in a beautiful setting, but it truly is an inspirational building and one that you feel extremely comfortable in. So these are a little bit of the views of the inside of our building, and I'm going to try to play. Just, is any of this streaming at all for you guys? Marcy, can you see any of this? This was the winner of 2018-2019, and this is how the site looked as we got started. And if it's not showing up, Marcy, I'll skip it. But here goes the steel. And so in April, finally, late April, the first wood starts to come on the site. Here it goes. And it took only about 10 actual working days for all of this wood to go up. There were a few little pieces, the eyebrows on the front doors didn't go into labor later, they said on the site, but most of the structural work on the wood was accomplished in less than 10 full working days. So I'm going to close that out now because they're just finishing up the building. We used about 282,000 board feet of CLT and 72,000 board feet of Glulam timber in this building. And as you notice, we did not do a post system. Our posts were steel because we wanted a very open, clear area within the building. And so that combination of a hybrid steel CLT and Glulam worked for us. When I did the totals, I looked at 20-inch pine trees grown here in the southeast and found that you would average about 400 board feet. And if I used every piece of board feet in there, I would be able to do this building with 885 trees. Now, in reality, not every one of those pieces of board or dimension timbers that came out of a tree goes into it, but it was the equivalent of only 885 trees. And if I grew those to an age of 25 or so before I harvested it, I could do that with thinning and lots of returns to my landowners and still pull that off in a harvest on 24 acres. So not a big area to go with. Really interesting ability and a very small amount of wood, frankly, to build that beautiful building. So when we have well-managed forest, when we have good design, and when we have buildings that are designed to where it's easy to maintain and where there is no water intrusion, so the exterior pieces, anywhere that water could hit on our building, we were very particular on the design details and how we were covering up and what our maintenance schedules and things are going to be. We can build sustainable, durable buildings that will last for many years. In fact, the buildings that are lasting for 100 years on my campus are actually heavy timber buildings. The buildings that were built in the 70s for concrete, with concrete and steel, and not built with, for right now, seismic design, are having to come down, and we're not being able to rebuild them or reuse them or renovate them. So we are seeing that really well done sustainable buildings can be built with mass timber. And so if you know anyone who's a building owner or school district, government buildings, universities, businesses, I encourage everybody to ask for wood. There are times when you won't have that happen, when someone won't give you wood as a choice. And so you really need to tell, if you're the building owner, you need to say, hey, I'd like to incorporate wood in this building. Can we use mass timber? Because we are at the very beginning of mass timber and not everybody's heard of it. And so we really want to move forward and push this out and be an advocate, because we know that when we look backwards, when we put wood in buildings, we encourage healthy management of sustainable forest. And all of us need to be an advocate and ask for wood. Clemson was pretty impressed with their new building, and so our second building going up is under construction right now. This is the Cadden Chapel. These are the diagrams from, or photos from, the architectural concept drawings. And it is a smaller building, but even here we're using mass timber. It has a moment frame of CLT, and it has glue laminated beams within it. And these are from Europe. So the cost system worked out to where they were able to produce these and get them in from Europe, and not use Southern Yellow Pine, which is what our other building is from. So I'm really excited about this building going in. So with that, what's in your future? This is me. You can find me at all these sites.
Thank you, Pat, for providing us with a very informative webinar. And thank you, everyone, for staying with us through the entire webinar. We apologize if you've experienced any technical difficulties, but from what we understand, this is not unique to this webinar. GoToWebinar is having some issues that may be a result of the higher demand on their system. Before we get into the Q&A portion of the presentation with Pat, I wanted to answer a question that came in related to the use of European products. When using glue laminated timber or cross laminated timber or any wood products for that matter, it's important to specify and use the products that are manufactured per the reference standard in the code. This slide shows the standards for glue laminated timber and cross laminated timber. And what is referenced may not be what the European products are being manufactured with. So if you are using European products that do not meet these requirements, that may cause some challenges when going through the design process and project approval process. And it will need to go through an alternate means and method approach when dealing with these products. Also, the design standards, such as the National Design Specification for Wood Construction, the wind and seismic provisions, all based on wood products being manufactured per these reference standards. So you want to verify all of this and make sure you have all your ducks in a row before specifying using some other products that are not manufactured per these reference standards. Okay, let's bring Pat Layton back in for the Q&A portion of the presentation.
There was a question related to distance and looking at sustainable material and having the availability of the material to the project. Could you speak on that a little bit, Pat?
Sure. As I said, there are multiple ways of having wood get, so when we can ship wood a long way when we can put it on water or trains, and even the finished pieces of CLT, for example, can be shipped a fairly substantial way. So our building is within 500 miles of a manufacturing plant, and as we grow the number of buildings that are being built with mass timber, we'll grow the number of manufacturing plants. So that our hope is that everyone will be within a significant range of a mass timber building. But today, we easily see, and as I mentioned in our second building, that mass timber is coming from Europe. It's being loaded onto a ship and transported very efficiently without a lot of extra energy and carbon that's being used to move that product here to the United States, and then transported up from our coast to our building and being put in place.
Great. And one thing also is, when looking at sustainable materials, is look at the big picture. What are the alternatives? Could you speak on that also?
Sure. There is a lot of folks who are talking about wood versus concrete or steel, and there are several tools out there to help you compare things, and so that you can think about the environmental impacts of all of the buildings and materials that are being used, and choose the right building and material to be more sustainable, more environmentally friendly. Green buildings, the LEED system utilizes a lot of wood, and they're acceptable of wood products and these wood buildings, and recognize their value, as does the Living Building Challenge that the architects have going right now, the 2030 Challenge for Living Buildings. They're saying that wood is a better alternative for meeting the goals that they have for reducing global impacts. And so really choosing to use a product such as wood that is renewable, reusable, recyclable, sustainably grown, and grown in well-managed forest is certainly better than some of the alternatives, and available. I mean, we are very fortunate that there is plenty of wood available, and in fact, if you talk to many state foresters, they would tell you that their states have too many trees, and they would love to see more trees being used. So it is a point in time where we are moving. We need to use wood, and we need to use it in buildings.
And that leads into my next question. I'm glad you said that about using trees. There are challenges throughout the U.S., and including California, where wildfires are a big issue. Could you speak on that, and all other areas of countries where forests really need to use the wood?
Well, I'll give you an example of our forest in the southeast. There's an active marketplace, and you can sell your trees. Now, where I am, we don't have a local pine sawmill close by, so we don't get as much money for our trees as I wish we did, but we can sell them. And so that's really good, because it helps us manage our forest and manage it with thoughtfulness, and to manage it so that our trees don't grow so old that they start falling apart, decaying, and get turned back into, and get overstocked, so that we'd have insect infestation or fire problems. In other places where there are not markets, or where markets are very lean, California being one of them and Colorado being another, we just don't have a lot of markets for those, and so there is no place. If you want to do timber stand improvement or thinning, or do any of the practices that might help your forest, you're not able to do that because we don't have a place to put the wood, to send the wood. And it can be very expensive to do those kinds of techniques if you don't, for a private landowner or even the federal land ownership. So for example, in Arizona, I was told there was a project where they spent millions of dollars to thin the forest, millions of dollars to thin the forest, with no return on the investment that they got, other than the fact that they did reduce fire damage. So there was no offset of that expenditure by having a marketplace for that wood to go to. The wood needed to be cut. We just, it would be helpful if we had an alternative market, a marketplace where we could use that wood, and it would help pay for that management.
Right. Supply and demand. Pretty much.
Supply and demand, absolutely.
Another, I think you commented in your presentation about alternate resources for learning about the future codes. For the audience, I am putting in a link to a webinar that was done by AWC on the outcomes of the Tall Wood Ad Hoc Committee, which goes into quite good detail on the provisions for the 2021 code. And you can watch that for free on our website.
I was going to add one more resource, and I don't know, this is another organization, but I know that you all work together, so I'm going to say this, and especially since we have so many engineers watching today. If you need help in a particular building or a particular spot, there is a program called Woodworks, which also has a lot of resources, but they actually have field agents that can help you with specific questions. And the APA also, that's the Engineered Wood Association, also has folks who are in the field that can help you with specific questions about products that you need if you have questions, and they're out there to help for free, as well as your Wood Council.
Yes, that's a really good point, and Marcy will speak more on the Woodworks aspect of helping with projects. She has a slide at the end, but great to remind the audience about that. And if you're dealing with code officials, please feel free to contact AWC. That's our forte, and you can contact us at info@awc.org. There is also a publication on the 2021 IBC that I'm also putting in the link. You can download that for free. That was co-authored by Woodworks and AWC. Could you speak to, there was a slide on forest management standards and FSC, SFI, and all of that. But for the small farmer who doesn't really necessarily use those standards, could you talk a little bit about the forestry management just across USA without even having those standards? Typically, most forests are managed sustainably? Can you talk on that?
Yes, to a certain extent. So there are I'm going to talk about the resources. So if you are a very small landowner and you don't live near your forest, or you're a distance owner, there are opportunities to use consulting foresters who can help you manage your forest from a distance. There are also opportunities for you to learn about how to manage your forest. And if you are familiar with the extension service that's run by the land grant university in your state, almost every one of those has a forestry program in their extension program, or maybe your neighboring state does, and many of them offer landowner types of classes and instruction, some of them online, some of them in person. And in some of these states, they have actual community or county-wide landowner associations or forest interest owner associations. And you can find more about those at your university, your extension service in your state. So one aspect for small landowners is to please reach out to their county extension office. There's a county extension office in almost every county in the United States, and find out more about wood through them and growing forest and how to grow your forest. Your state forestry organizations also have outreach services. And they can actually help you. If you're a very small farmer, they can even help you write a management plan or get you a management plan written for your forest, so that you know all about your forest, what's in your forest, the soils of your forest, and what steps you need to do to sustainably manage your forest. If you're active and you want to get involved and you start with your management plan, you can then join the American Tree Farm System, and many people do that, and they are very active in many states in the union, and they can go up. They usually have up to about 10,000 acres, you can be a member of the tree farm system. I think above that, you're probably looking at one of either the FSC or the Sustainable Forestry Initiative. Both of those programs, all of those programs are online, and you can find out more about them. Many states have a tree farm committee, a state tree farm committee, and you can contact your local state tree farm committee. Just Google it or call your state forestry organization, and they can, or state forestry public agency, and they can help you with that.
All right, thanks. Another question came up about, I'm trying to find it, having to do with one of the slides. I'm kind of jumping all over the place, but can you expand on the reason for mixed materials such as CLT and then NLT in floors inside a building? I don't know.
Sure. When we make or when we develop CLT, cross-laminated timber, if you looked, and I will go back to that picture, if you guys will just give me a second, if I can just form this picture. Okay. If you look at this picture, you can see that when you manufacture CLT, you make long pieces of wood, 40 to 60 foot long, by finger joining 2x6s and 2x8s, and you lay those down, you put glue on top, and then you come in with a wide, across the opposite direction, perpendicular direction, and you do the same thing. You lay wood across there, so that might be 8 foot wide or 10 foot wide, depending on your manufacturer. Then you come back with another layer in the long direction. The way we direct these, or the way we do long and short directions on this, can vary to some extent depending on the purpose of the material. But by crossing or laying those down in perpendicular layers, we make an engineered piece of wood that has strength in 2 directions. When we choose to use nail laminated timber, we have strength in only 1 direction. So the panel will have different properties, and those different properties are chosen in the engineering design of a particular building. The nail laminated timber that you see here has strength in 1 direction and may be used in a different size mode, for example, or different needs for strength than a cross-laminated timber panel. So it really is about how you're engineering the strength of the building as to which you choose. Nail laminated has been used for flooring traditionally, and even in old heavy timber buildings, nail laminated timber, there's an architect in Greenville, and they've moved into a bread factory that was a really old building, and they've renovated it beautifully. And it's Glulam beams or heavy timber beams, but if you look above you, the ceiling above you is nail laminated floors from that old mill. So that's what we're seeing there.
Yep, and you're right. The nail laminated timber, it's actually in the building code called mechanically laminated timber. Yep. And it's been around since at least the 60s. I know I've seen it in the building codes that old.
The disadvantage, there is one disadvantage to it, but with modern saws that may be changing, is that if you forgot to put a hole through that floor that you needed access to get to the upper floor for some reason, it's really hard to drill a hole or cut a hole in it. With CLT, because there's no nails, you can easily use a saw on site and cut a hole if you need to. Not that we want to do that too often, but it can be done.
We want to check with the engineer.
Check with your engineer, yeah.
Right. And some of it has to do with also availability of materials too, I think.
Correct.
On what they choose and ease of construction, etc.
And the other thing is the nail laminated timber can be built on site, or close by. And if you're bringing your Glulam may have to come from a ways away, or your CLT may have to come from a ways away. You actually can rig up systems on site and build your nail laminated floors or nearby. So the Candida building at Georgia Tech University, which just opened in the past 6 months, has nail laminated flooring. It is a combination of 2x6s that were brand new and recently graded, and 2x4s, which were recycled or being reused from an other building that was on the Georgia Tech campus and had been deconstructed such that they could reuse those 2x4s. And so it gives you a wavy pattern on the ceiling, and it is a new piece of wood and an old piece of wood and a new piece of wood and an old piece of wood, and they built them right there on site. And it was a wonderful use of reusing existing wood as well as the strength of a new wood product and using it in that building.
That is very interesting. And when people want to use, or designers want to use, reuse wood, it does need to be regraded. Those are the rules, or
yeah. In this case, it was their reuse was aided by the fact that the engineering found that the 2x6s were carrying the most of the strength of that building and so I think they were inspected, but I'm not sure it required. But anytime, and I've had the question, I'm just going to throw this out. I had a builder that wanted to use a tree that was cut down on a property, and he wanted to use a natural tree as an exterior post on the front courtyard of a building.
Interesting.
And you can't, because people were going to occupy it. It also, according to building code, had to be graded. And so I will say that if you know who the grading people are in your state, so for Southern Yellow Pine, the Southern Yellow Pine folks set their grading rules, and they have inspectors around, and they can come and inspect if you don't buy it from a regular sawmill or a regular distributor where it's already been inspected. You can get an individual inspection done.
That is interesting. Okay, I think, do you want to have one more question? And then we'll bring in Marcy. So hopefully.
Just keep in mind that we do need to go until 12:30. I apologize, but we really need to go till 12:30 for people to get their credit.
Well, while we're waiting, and I didn't show very much of it, I could show a little bit more of this slide where we were building our building here at Clemson. So let me go to full screen. Y'all can still see my slides, I assume.
Oh yeah, we can see your presentation. Another aspect in choosing the system is, what does the architect want to see when they're looking up at the ceiling? Do they want to see nail laminated timber or glue laminated timber? There are also systems where we're using glue laminated timber beams that are set flatwise.
Yes, absolutely. And in fact, one of the interesting pieces about this building, and I was looking at the data the other day, we used the CLT. Some of the people who bid on this building did bid to do it in not mass timber, but to bid on it using steel or traditional other normal alternative materials. And because we did it with wood and had an architecturally visible ceiling and did not have to add sheetrock or other materials to this, this building, as it is built, came in below cost of the other types of traditional building materials. So they bid it always, and it did come in below cost. So while people think it's expensive, it may not be as expensive as you think. And again, you can't look at a square meter or a square foot of concrete and a square foot of CLT, for example, and just use those of, well, this price is going to be more or less, because it is a building system, and you have to look at the total prices of the buildings. And in fact, with our building and with the Lend-Lease hotels, and there are webinars that are out there about the Lend-Lease hotels, you find that the speed at which these buildings were constructed and the fewer number of people that it took to construct the building, the price goes down substantially on the total cost of the building.
That is a very good point.
And I think that's something that's really important. I think it's also very important, and this I'll add for the engineers, When you're working with the architects, and you're starting to design a building, because we don't have a specific standard of exact sizes for CLT, they can come in different widths and dimensions depending on the manufacturer, and even the dimension of the lamb stock itself made to be different from Europe to North America even. It's important to understand what product you're using early on. So really reaching out to the products and getting bids for working with one producer or another is important. And then getting their help in thinking about your building and your design and your engineering. There's a very good webinar that I've seen by Greg Kingsley that talks about, by choosing the distance between beams, or how you organize the bay structure, the repetitive bay structure of the building that he's looking at, you can greatly impact the cost of the materials that are in your building. And he does a great job on his seminar that also includes what it would cost in steel or concrete and what those alternatives were. And they too also vary, but the wood substantially varies. And really you can optimize that amount of wood you're using without waste, and really enhance the constructability and use of that wood, and make it even more importantly used. Also, how you connections are important, also thinking about those connections, the cost of those connections, what connections you're using, whether they're going to be hidden connections or visible connections, and all of those impact the cost of the building, and you need to be thinking about that ahead of time. So really working early on along all of those methods. And another thing I learned when building our building is that the earlier that you bring your subcontractors in so that they understand where HVAC is going to go, how HVAC needs to move from one floor to another, where the electrical conduits are going to go, how, if you've got a Glulam system, are they going through the Glulam, parallel to the Glulam, how they're going to be put. And then a key note for our building, we put up the conduit for our electrical, and it looked so out of place with these ugly silver conduits in the ceilings of our building. And so we painted them. So if you know it ahead of time, go ahead and paint the conduit when it's on the ground, and then put it up, and then you just have to touch it up. It would have speeded up the system and of our building immensely. But the conduit went in on a Sunday one day, and we got back, or a Saturday and a Sunday, and we got back, and there it was, and it was like, oh no, this is not the look we want. So really thinking about the look and picking out the colors, and everything needs to be done ahead of time. So a learning piece here is that the design and development and 3D renderings and models of these buildings are a longer upfront time than we may be used to in some cases. But when you get to the actual construction, the more you've done up front, the faster your building is when you go through, and how fast you can put it together. And that time saves money, always.
Great advice. So one more closing thought and question for you, since you've been in the industry for a while and you've experienced this project and seen changes in your area. What do you think is the future for mass timber? What do you see is the future?
Well, I used to work for a manufacturer of products that were household products, and our marketing guys taught me that a new product comes in as fashion. No, fringe. It comes in as a fringe, so it's a fringe thing to do. Only a few people adopt it or accept it. Then it becomes fashionable, and then it becomes fabric. And so that is their decision about how you have a new product coming to market, is going in as a fringe, then a fashion, and then the fabric. And so where it's used by everybody. I think that mass timber, especially when we understand it and we have our building codes, we are probably quickly moving from fringe to fashion, and I don't think we'll be in fashion very long. I think we will move within a decade to where this is the product that most mid-story buildings are manufactured out of or built out of. And I think we're going to see a lot of development, and I really encourage the use, and we will move quickly from fringe through the fashion status and go into the fabric. And I encourage everyone to visit a building so that you too can feel this. It is so different. It is such a different feeling to walk into one of these buildings than it is in any other building type. Please go visit one.
Totally agree. Totally agree. Well, thank you, Pat. That's a very great, really good presentation, and thank you for presenting for us.